box plots. Our objective, we want to draw and interpret box plots. Let's remind ourselves of a couple of things we already know. We know what the 5-number summary is. It is the 5 values: minimum value, Q1 value, median value, Q3 value, and the maximum value. And we know what fences are. They are cutoff points for outliers. And these cutoff points are calculated as follows. The lower cutoff, Q1 minus 1.5 times the IQR. And the upper cutoff, the upper fence, Q3 plus 1.5 times the IQR. So what is a box plot? A box plot is a graph of the numerical data based on the 5-number summary. By the way, it's also called a box and whisker plot because, as you can see here, some people speak of these as whiskers. Here are your 5 numbers: lowest value Q1, median Q3, and the highest value. And you can see there's a box around the interquartile range, and then whiskers out to the highest and lowest values, unless you have outliers. And we'll talk about that, and we'll see that in just a moment. How do you draw it? Well, here are the instructions. You first need to determine the upper and lower fences, so that means you need to determine the IQR. Then we're going to draw the number line. And then we're going to insert vertical lines at Q1, the median, and Q3, and draw a box around that. We'll draw temporary brackets for fences. We're then going to draw the whiskers, as some people talk about, from Q1 to the smallest value that is within the fence, and from Q3 up to the largest value that is within the fence. Okay. And then we will erase the fences, and any values that are too large or too small that are outside of the fences, we'll put an asterisk down. Okay? A lot of words, not quite as bad as all those words seem to make it sound. Let's take a look here. Okay. The data in the table below show the finishing times in minutes of the men in the 60 to 64-year-old age group in a 5K race. Let's see, 3, 2, 3, 4, 5, so 21 times. We had 21 men in the 60 to 64 age group. The 5-number summary is, so we've already calculated that. This is the minimum value, which is right there. This is Q1. This is the median, 30.95 minutes. This is Q3. And 5463 is the maximum value. We want to construct a box plot. Well, as we mentioned, we can't find the fences if we don't know the IQR. So let's first come up with the IQR. Q3 minus Q1. Q3 is 37.24. Q1 is 26.06. Our interquartile range is 11.18. This allows us to find number 1, our lower fence and our upper fence. If you're inside the fence, you can be part of a whisker. If you're outside the fence, you're going to be an asterisk. The lower fence limit, Q1 minus 1.5 times the IQR. Whoops, yep. I'm sorry, that's correct. Q1, 2606 minus 1.5 times the interquartile range, 11.18. We do the math, and we come up with 9.29. If any of our men runs faster than 9.29 minutes, he is an outlier. He is very far away from the median. Now, we already know that our slowest time here is 19.95. Nobody was faster than that. So this lower fence isn't going to come into play for us. Okay, the upper fence. is Q3 plus 1.5 times the IQR. Q3 is 37.24 plus 1.5. The interquartile range is 11.18. And our upper fence is going to take place at 54.01 minutes. If anybody ran slower than 51.01 minutes, took them more time, their time was higher, that person will be an outlier. And we can already look and say, yep, we've got one person who is slightly above our upper fence. This person is going to get an asterisk when we create our box and whisker plot. Okay, 2 through 5. Whoops, I meant to write that as 2-5. Steps 2 through 5. Let's draw a number line. And we need to go from 0 to 60-ish. 0, 10, 20, 30, 40, 50, 60. Okay. And let's we include the minimum and the maximum. We're good here. Let's see. We need to insert vertical lines for our 3 quartiles. So 26 ballpark here for Q1, 31-ish is about there, and 37.25 is about there, let's say. So here is our box, draw a box around it, and there's our box. Q1, median, Q3. This is our middle 50% of the data values. Slide that up for you. Okay. Now, our fences. One fence is at 9.29. Well, that's way the heck down here. And one fence is at 54.01. And that is ballpark here. Okay, so we've got our fences. Now, we want to go from here to the smallest data value that is larger than the fence. We already know that this is our smallest value, and that number is way larger than our lower fence. So our whisker will go out to 19.95. There's our whisker. That fence is fine. No need. We don't need it. There's nothing beyond it. So so we don't need to worry about that anymore. We'll erase that bracket. Now, upper fence is at 54.01. We have one value that's above that. That's going to be an asterisk. So at 54.01, that's an asterisk. Excuse me, at 54.63, that's an asterisk. And we'll draw our whisker out to the next highest value, the highest value before the fence. The highest value before the fence is 49.17. So we'll go out to 49.17, approximately there. And again, we'll erase that fence and note this with an asterisk. Okay? So the fences aren't part of the drawing. They assist us with the drawing in with marking outliers as necessary. All right, so that's how you do a box whisker plot by hand. We'll do one using StatCrunch in just a moment. Let's take a look at the histograms and their corresponding box plots. So we've talked a whole lot about, and we're going to talk more about a symmetrical distribution, bell-shaped, a normal distribution, in which the median equals the mean, and we have roughly symmetrical left and right. And you can see the corresponding box plot has whiskers that are essentially the same length. Okay, so that's how these two things, you look at this box plot and you'll say, that looks like that may be a normal distribution because I have equal length whiskers. Okay, in general, of course, your median is also somewhat centered as well. Now, here are the two that are skewed. Remember, skew right means you have a right tail. Skew to the left means you have a left tail. And here are their corresponding box plots. We wind up with a skewed right box plot with a longer whisker on the right side. And we wind up with a skewed left box plot having a longer whisker on the left side. Okay, so that's how these things kind of relate to one another. If I look up here, there's some symmetry here, but I would suggest this has a skew to the right. Okay, because we've got a fair amount more here with this whisker being a fair piece longer than this one, plus we have this outlier. So this one probably has a skew to the right, skewed to the right. I'm pointing to the wrong one, skewed to the right histogram. But there's your corresponding histograms and box plots. Okay, let's do a quick look at box plots using StatCrunch. And give me a moment here. I seem to have, I just lost my iPad. Oh, there we go, back up. Okay. And I'll get this set for you. It's kind of tough. I've got the phone going, plus I've got the iPad going, plus I got to get this centered. A lot of things happening. No big deal. A student wanted to know whether Centrum vitamins dissolve faster than the corresponding generic brand. So she used vinegar as a substitute for stomach acid and measured the time in minutes it took for a vitamin to completely dissolve. The results are in StatCrunch 3_5_15. Let's use StatCrunch, graph, box plot, and we're going to check the draw boxes horizontally so we can see them in horizontal, a little easier to read than vertical, to draw side-by-side box plots of each vitamin type, and we'll answer these two questions. Which vitamin has the greater spread? Dispersion is spread. Which vitamin appears to dissolve faster? Okay, let's go to StatCrunch and get this up here. Well, that's got a magnetic field piece to it on my clipboard. And that's not quite, well, I don't know, it's not seeming to, that's got it, but for some reason it's not, well, I think we'll be okay. We want to go to 3.5.15. 3.5.15 is right there. And here's the data. So we got Centrum and we got the generic brand. You can see the column headings here. How many data points do we have? Oh, so much she did 30 each. Okay, let's do side-by-side box plots. So we'll go to graph, box plot, and that's down here. Okay, box plot. All right, columns. I want to do both. I can select both. Okay, and I'd like to draw them. I'll use fences for outliers and I'll draw them horizontally. Okay, it's a little easier to read and I'll compute. And it looks like there are no outliers because I don't have any fences with asterisks. But you can see, again, here are the minutes. So this minutes went from 2 to, looks like maybe a little over 7. And you can see this is the generic brand box plot. They both look like they're relatively normal. This one might have a little skew to it, but they're relatively symmetric. First question, which has more spread, more dispersion? Well, this one goes from about 2 to about 4.25. This one goes from about 5 to about 7.5. So it looks like this one has more dispersion in the generic brand. There's more spread in the data. There's certainly more spread in the interquartile range. This box has got more width than this box. So I would suggest the generic brand has more dispersion, more spread. Which type appears to dissolve faster? Well, dissolving faster is time. And it's pretty clear that Centrum, dissolving between 2 and 4+ minutes, is dissolving faster than the generic brand, which dissolves between about 5 and 7.25 minutes. So which has more spread? The generic. Which dissolve faster? Very clearly, the Centrum dissolves faster. So we'll go back to here, we'll answer those two questions, and we'll call it done. Okay, letter A, more dispersion. The generic has more dispersion. Again, dispersion is a statistical word. Spread is kind of the same idea. Which dissolves faster? Centrum dissolves, or appears to. How about that? Centrum dissolves faster. And there you have it, box plots.